Welcome to Lesson 7, Logical Operators. In this video, we're going to apply our understanding of logical operators to the Circuit Playground Express and check the status of various components in the Circuit Playground Express. We're also going to discuss, how are these logical operators evaluated in terms of the order. So let's get to it. So I've already done some coding up front just to save us a little bit of time. So I got variables for the left, right, and slide switch. I've also created a function called inputs, which handles the assignment of the values from the Circuit Playground Express to those variables, and I call that function in the loop. So that means that we're continuously calling, checking the status of our components. I've also created another function called magenta, which simply just colors all the neopixels to magenta, just so we have something visual to work with. So the first one we're going to test out is the AND operator. And what we're going to do is, let's have it so that the user has to press both buttons in order to see the color magenta. So we're going to check for left button to equal 1 and right button to equal 1. And if that's the case, then we're going to go ahead and color the inputs. Let me actually do this too, or else we're going to not see it. So recall, anytime you work with the neopixels, you typically want to clear it unless there's a scenario where you want to actually retain what the previous color was. So we're going to clear all the neopixels, and then this allows us to check. And let's also throw a small delay in here. Say 100 milliseconds should be fine. And let's go ahead and run this. So as you look at the Circuit Playground Express, you'll see none of the lights are turned on. So I'm going to try to press one of the buttons. There's no lights turned on. I'm going to try to press the other button. No lights turn on. Again, because if you look at the decision, it says the left button has to equal 1 and the right button has to equal 1. So it's only when I press both buttons that the light turns on. Okay. So again, just as an intuition, that is how the AND operator works. All conditions must be met. All right, so now let's flip this around to the OR operator. And let's go ahead and upload this. Now, if you recall, the OR operator works a little bit differently. The OR operator evaluates to true as long as one of the conditions is true. So in this case, I'm going to press the left button. Okay, that's enough. Now I'm going to press the right button. That's enough. Again, because it says it's either the left button equals 1 or the right button equals 1. Now, if I wanted to, I could press both. That's okay as well. The only time the decision doesn't work now, or doesn't evaluate to true, is when none of them are pressed. Because at this point, both the left button and the right button have values of 0. So again, just as a quick application, the AND operator, everything has to be met. The OR operator, at least one of the conditions has to be met. Now, I've done this with the buttons, but honestly, you can work with any of the CPX components. So right now, what I've done is I've switched it over to the slide switch. And let's evaluate this one. And we're going to do this one slightly in reverse. So we're going to explore the OR operator first. And what you'll notice right now is that the lights are turned on. The lights are turned on because my slide switch is to the left. So I'm going to switch it over to the right now. So let's look at the decision. So the decision is asking, is the slide switch a value of 1, which is to the left, or is the right button being pressed? Well, right now, neither is happening. But let me go ahead and press my right button. So notice my slide switch is still to the right, which means it has a value of 0, But because I pressed the right button, now the second part of that decision is working. Again, I could go back to the original one, which is I could put my slide switch to the left, and at this point it doesn't matter if I press the right button or not. The slide switch is to the left, which has a value of 1, so the OR expression is working. It's evaluating to true. Now if I wanted to, I could do this as well. It's not going to matter because the slide switch is already to the left. Now let's explore the AND operator with the slide switch. Okay, so right now, because the lights aren't turning on, you can actually figure out that the slide switch must be to the right, even though I know it's hard to see, and obviously I'm not pressing the right button. Because you recall, it's not enough for one condition to be met. All conditions have to be met. So let's test out that logic. So I'm going to press the right button. Oops. This happened before too. Oh, which way? I'm sorry. My slide switch was actually to the left. So now my slide switch is to the right, which means the first part of the condition is not met, and I'm gonna press the right button. Okay, so notice the slide switch is to the right, which means it has a value of 0. And right now, my right button is not being pressed, which means it has a value of 0. Now if I press the right button, nothing happens because guess what? The slide switch has to be left. So I misspoke earlier in this example. So at this point, the slide switch is to the left, and I'm going to press the right button, which means I get the the magenta color to come up. All right. So again, with an AND operator, both conditions have to be met. So the slide switch had to be to the left, and the right button had to be pressed. Now, let's make a more sophisticated example of this, which is, what if we wanted the slide switch to have to be to the left, and the person can press either button? So we could do this. We could press, have the slide switch to the left, and check to see if either button is pressed. Now I'm going to give you a little heads up. There's something wrong with our logic here, but I want to do it through an exploration. So let me just double check what I have. Okay, so right now my slide switch is to, actually let me do it this way. My slide switch is to the left. Okay, so at this point, now with my slide switch to the left, I have to press either the right button or the left button. Okay, so right now it appears that our logic is working in that we wanted to be able to use either button when the slide switch is to the right, to the left, which is a value of 1. Now let me switch my slide switch to the right, which means I should not get any of the lights because the slide switch had to be to the left, and then I had to be able to press one of the buttons. So let's try the right button. Okay, nothing happens. But now let's try the left button. See, that should not be the case. It's almost, think of this as an on-off switch, the way we're applying it in our logic. And then once the on-off switch, once the switch has been turned on, then we can press the buttons. But right now, it's in the right position, which is our quote-unquote off position, but I'm still able to turn it on. All right, so why did that happen? Because the way the computer works is that the AND operator has a higher order precedence over the OR operator. And what does that mean? This is what the computer sees. Okay, so you want me to check to see if the slide switch is to the left and you press the right button. That's all it checks right now. Once it evaluates that expression, then it checks, oh, and then you want me to check to see if the left button is pressed. So our logic was more that we wanted the slide switch to be to the left, quote unquote, an on-off switch, and then allow the ability to press either button. So here's where we have to borrow another operator, parentheses, kind of like in math. If you recall, parentheses have the highest order of operations. They're going to happen first, and it just doesn't apply to mathematical expressions. It can actually apply to logical expressions as well. So by putting parentheses here, we're forcing the computer to evaluate this expression first, that either one of these two buttons were pressed and then the slide switches to the left. So let's see this logic. All right, so right now, let's go back to the first part, which is the slide switches to the left. And let's just make sure that what we want to happen is still happening, which is, quote unquote, if the circuit playground is on with the slide switch, I should be able to press either button to make the lights turn on. Now, with the slide switch to the right, quote unquote, our off position, I should not be able to press either button. And that's the case, okay? So it's important for you to realize that when it comes to combining multiple conditions, and that's what you're seeing here, logical operators allow you to combine as many conditions as you want in whatever order you want. But just make sure that you understand that the AND operator, no matter how you think it's going to be evaluated, this gets evaluated first before an OR operator. Again, if you're mixing the two together. So if you want to force the OR operator to happen first, you got to wrap it in parentheses. All right, so let's go back to our presentation. And in this video, we saw an application of logical operators of AND and OR to the Circuit Playground Express, specifically using the left, right button and the slide switch. But honestly, you can do these conditions with any of the components. For instance, you could possibly check light levels and a button being pressed, the sound levels and the orientation of the Circuit Playground Express using the accelerometer, the motion Y. So honestly, your creativity is left to creating these decisions in whatever way you want to, for whatever effect you want. So logical operators are very powerful, and hopefully now you can really express what you want to do with the Circuit Playground Express. Take care.